Welcome to this video on confidence intervals, example 1 with categorical data. This video will answer the following questions. What are the four main parts of a confidence interval? What assumptions and conditions must be met to create a confidence interval for categorical or qualitative data? What are the 5 steps of constructing a confidence interval? How do you use manual calculations to create a confidence interval for categorical or qualitative data? How do you use technology to create a confidence interval for categorical or qualitative data? And lastly, how do you write a summary sentence to describe a confidence interval for categorical or qualitative data? Let's begin. Example 1. Alcohol abuse is a serious health problem on college campuses. A nationwide survey of students at 140 four-year colleges in the United States defined frequent binge drinking as having 5 or more drinks in a row 3 or more times in the past 2-week period. Of the 17,096 students surveyed, 3,314 met this criterion. Assume the data represent a simple random sample of four-year colleges. Calculate the prevalence of frequent binge drinking. Include a 95% confidence interval for the estimate and write a sentence stating your results. Round all values to 4 decimal places as needed. Steps to constructing a confidence interval for categorical data. First, we must check all assumptions and conditions. Then we will identify the variables and enter the data into StatCrunch or calculate values manually. Then we can construct the confidence interval, identifying the lower and upper limits, point estimate, and margin of error, and lastly write a sentence to summarize our findings. Let's start by checking our assumptions and conditions. The first requirement is that there are 2 outcomes, success and failure. In this case, we define success as being a frequent binge drinker and failure as not being a frequent binge drinker. Remember, in statistics, success is usually defined as the presence of an attribute, and failure is usually defined as the absence of an attribute. Unlike regular life, where we would consider success a positive thing and failure a negative thing, these terms do not have the same connotation in statistical applications. Next, we need the probability of success P to be constant. So the probability of success will be approximated using our sample proportion p hat, which is given as 3,314 over 17,096. So we will consider this to be a constant. Next, we need to know that each trial is independent from the others. Here we have to assume that the survey results were independent from student to student. In other words, the results of one student did not influence in any way the results from another student. There also needs to be a fixed number of trials. In this case, we are told that the number of trials is 17,096. Next, we need to know that our n times p hat times q hat is greater than 10. To do this, we'll have to do a little bit of math. So our sample size n is 17,096. Our p hat is about 0.1938. And our q hat, remember, which is 1 minus p hat, is about 0.8062. When we multiply these together, we get 2,672, which is much larger than 10, so we can say that this condition has also been met. Now that we've completed step 1, we can move on to step 2. In step 2, we have to identify all of our variables. Fortunately, we've already identified some of our variables in the previous step. We know that our sample size n is 17,096. We know that our p hat, or our sample proportion, is about 0.1938, and we also know that q hat, 1 minus p hat, is about 0.8062. To calculate the margin of error manually, we will use the following formula. The margin of error is equal to z of alpha over 2 times the square root of p hat q hat over n. As you can see, we have all of these values except for z of alpha over 2. To understand what this is and how to calculate it, please watch my video on this topic. For now, we will use this table here to figure out which z value we need based on the confidence level. Let's go back to our problem statement to figure out or to remember what confidence level we are being asked to find. Here you can see that we're being asked to find a 95% confidence level. So what does that mean? That means that our z value here is 1.96. Again, to understand how to get from the confidence level to the z value, please watch that video. So now we can manually calculate the margin of error. So again, we have our sample size is 17,096. We have our sample proportion is 0.1938. We have our q hat, which is 1 minus p hat of 0.8062, and we have our z of alpha over 2 is 1.96. Plugging all of these values into our equation for the margin of error, we find that our margin of error is about 0.0059. Make sure when you're rounding, you follow the directions that are given in the problem. In this case, we were asked to round to 4 decimal places, so that's what we have done. Step 4, constructing the confidence interval. I'll start with the margin of error that we just calculated and fill that in. Remember, your margin of error is always positive. So in both cases, the margin of error is 0.0059. We are also given the point estimate p hat, which was 0.1938. What are we missing? Well, we're missing our lower limit and our upper limit. As you can see, we will have to calculate these by using the point estimate and the margin of error. We've done that down here. So the point estimate, 0.1938, minus the margin of error is 0.1879. So that's our lower limit. Likewise, we can find our upper limit by adding the margin of error to our point estimate, and we get about 0.1997. So our picture of a confidence level is now complete. What if we, instead of using a manual calculation, wanted to use technology to calculate the margin of error and construct our confidence interval? To do this, we would go to StatCrunch and then go to Stat, Proportion Stats, One Sample with Summary. When you click on that trail, it gives you this input screen. The first thing that we need is the number of successes, then the number of observations, or the sample size n, and lastly, the confidence level. Here you can see that the problem statement gives us n equals 17,096. So you can enter that in, making sure to leave out any commas because StatCrunch does not understand commas. We see that the number of successes is 3,314. So again, we can enter that here. And lastly, we have a confidence level of 95%. Now, notice that we need a decimal here, so we have to convert 95% to 0.95 before entering that there. Now that we have these values, we can hit compute. And once you hit compute, this is the screen you will see. So there are 3 values that we need to capture and write down in our notes from StatCrunch. The first is the sample proportion, which is, you can see here. Then we have the lower limit, and we have the upper limit. One thing you need to notice is that there is this thing called a standard error here, and we do not want to use that. It is not the same as the margin of error. If you want to figure out what the standard error is and how to convert it into the margin of error, you can ask your instructor. But for now, we're just going to ignore this piece of information. Another thing to notice is that the upper limit is 0.1997722, and if we round it to 4 decimal places, it actually rounds to 0.1998, which is a little bit different from our manual calculations. You should expect a slight discrepancy, not a large discrepancy, but a slight discrepancy between manual calculations and computer calculations, because most often when you're doing manual calculations, you're going to have some rounding error. So please keep that in mind and don't panic if you see some slight differences between StatCrunch and your calculations by hand. Let's keep going. So now that we have our StatCrunch values, we're going to once again construct our confidence interval using these values. So we have the same point estimate, which is 0.1938. This time, StatCrunch gave us the lower limit and the upper limit, so we'll fill those in. Again, noting that the upper limit is slightly different, again, because of rounding error. And then we have the margin of error, which StatCrunch, as mentioned before, did not give us. It gives us a standard error, and again, that is not the same as the margin of error, so we cannot use that. So we actually have to compute the margin of error by subtracting the lower limit from the upper limit and then dividing by 2. We're literally finding the distance from here to here and then dividing that in half, because as you can see, there are 2 margins of error between these upper and lower limits. When we do that, we find that the margin of error, again, is slightly different. Before it was 0.0059, now it's 0.60, because, again, of some rounding error that we had in our manual calculations. So now we are finished. We have our complete confidence interval, and we can move on to step 5. Remember, your margin of error is always positive. So step 5 is to write a sentence to summarize the confidence interval. The summary sentence for confidence intervals is very straightforward and formulaic. When working with categorical data, we use the following sentence structure. We are confidence level confident that the true population proportion of give problem specifics here lies between the lower limit and the upper limit. For readability, we often convert the lower and upper limits to percents by multiplying each value by 100%. In this problem, we already know that our lower limit is 18.79% and the upper limit is 19.98%. We can return to the problem statement to find the remaining information we need to construct our summary sentence. Here we see that our population is students at four-year colleges, and we see that the characteristic or the measure of success in this example is frequent binge drinking. Both of these should be included in our summary statement. Lastly, we can see that we are asked to find a 95% confidence level. So, using this template, we can say that we are 95% confident that the true population proportion of frequent binge drinkers among students at four-year colleges lies between 18.79% and 19.98%. So our problem is now complete. Notice again that the descriptor includes both the population being studied and the characteristic that's being defined as success. Now that you've watched this video, you should be able to do the following. What are the four main parts of a confidence interval? What assumptions and conditions must be met to create a confidence interval for categorical or qualitative data? What are the 5 steps of constructing a confidence interval? How do you use manual calculations to create a confidence interval for categorical or qualitative data? How do you use technology to create a confidence interval for categorical or qualitative data? And lastly, how do you write a summary sentence to describe a confidence interval for categorical or qualitative data?